Hi everyone, my name is Akhilesh. Today we are going to discuss about linear search, which is a type of searching technique. First, we want to know that what is a searching technique. Searching is a fundamental operation in computer science that involves locating a specific element or value within a given dataset. The process is crucial for various applications such as databases, information retrieval, and sorting algorithms. Searching can broadly classified into two main categories: linear search and binary search. Linear search, also known as sequential search, is a straightforward method that examines each element in the dataset one by one until the target element is found or the entire dataset is traversed. It is suitable for small datasets or unsorted arrays, but becomes inefficient for larger datasets due to its linear time complexity of big O of n, where n is the number of elements in the dataset. Next, on the other hand, binary search is more efficient approach applicable only to shorter datasets. It operates by repeatedly dividing the dataset in half and comparing the target element with the middle element. Based on the comparison, the search continues in the left or right half. Reducing the search space in each iteration, binary search has a time complexity of capital O of log n, making it highly efficient for larger datasets. In addition to these basic searching techniques, there are specialized organisms like interpolation search, exponential search, and hash-based search. Each approach has its strength and weakness, making them suitable for specific scenarios. Efficient searching is crucial for optimizing the performance of applications that rely on data retrieval and manipulation. The choice of the approaching search algorithm depends on the size of the dataset, its organization, and the nature of the data being searched. By understanding the various searching techniques, developers can make informed decisions to ensure efficient and reliable search operations in their program. Next, we know what is a linear search in C language. Linear search is a basic search algorithm used to find the presence of a target element in a list of array. It sequentially examines each element in the list until a match is found or the entire list is searched. In C language, this search can be implemented using a loop, starting from the first element to the last. If the target is found, the index is returned. Otherwise, a special value like -1 is returned to indicate the absence. So, simple linear search is less efficient for large datasets, as it has a time complexity of O of n, where n is the number of elements in the list. What is a linear search? Linear search, also known as sequential search, is a straightforward searching algorithm used to find the position of a specific value with an array. The process involves systematically examining each element in the array, starting from the beginning until a match is found or until all elements have been checked. To execute a linear search, the algorithm iterates through the array, comparing the target value with each element. If a match is found, the search terminates and the position of the target value is returned. However, if the entire array is traversed without finding the desired value, the algorithm concludes that the value does not exist in the array. While linear search is simply to implement, it is not the most efficient method for the large datasets, as it has a time complexity of O of n, where n represents the number of elements in the array. As a result, for larger datasets, more advanced searching technique algorithms such as binary search or hash tables are preferred due to their faster search times. Let us discuss algorithm for linear search. Step 1. Start the search from the first element of the array. Step 2. Compare the current element with the target value. Step 3. If the current element matches the target value, return the index of the element and exit. Step 4. If the current element does not match the target value, move to the next element and repeat step 2. Step 5. If the end of the array is reached without finding a match, return a not found indication. Linear search is simple and innovative algorithm for finding a specific value in an array. But as mentioned earlier, its complexity is O of n, where n is the number of elements in the array. Hence, it may not be the most efficient choice for large datasets compared to other algorithms like binary search or hash tables. For our brief information, let us discuss some code as example. Here is an example code for linear search by using functions. Here, first, the linear search function takes an integer array, its size n, and the target element we want to find. This line. Next, it uses a for loop to iterate through the array from the first element to the last element. I starts from 0, goes up to n minus 1. Here is the for loop. Inside the loop, it checks if the current element array I is equal to the target. Here we check that array I is equal to target or not. If the target element is found, it immediately returns the index I, indicating the position of the target element in the array. Here we will return I if the index is element is found. If the loop finishes without finding the target element, the function returns -1, indicating that the target element is not present in the array. If it is returned -1, if the target element is not found in the array, then here is the main function. In the main function, an example integer array is declared along with its size n and the target element to be such. An example array and its size n is indicated. We want to find the target 7. Then the linear search function is called with the array, its size, and the target element, and the return result is stored in the result variable. If the result is not -1, it means the target element was found, and its index and value are printed to the console. If the element is -1, it means the target element was not found, and a corresponding message is printed to the console. Here, if the target element is found, the result is 1, then we print that element is found at index D. Then, if the element is not found, we print that element is not found in the array. Let us run the code. Here, running the code. Here, element 7 found at index 2. Then, let us take another target. We will take some 1. Then, we will run the code once again. Here, element found is index 3. 1 is found at index 3. Index 0, index 1, index 2, it is index 3. It is found at index 3. Then let's take example which is not in these example code. Let us take some 6. Oh, 16, sorry. 6. Let us run the code once again. Here 6 is not in the given example. Here, we found the output as element 6 is not found in the array. So the code is executed. Previously, we executed a code example as for linear search. But in linear search, we face some complexities. Let us discuss what are the complexities. In the worst case scenario, when the target value is not present in the array or is located at the last position, linear search will need to traverse the entire array to determine that the value is not present. As a result, the time complexity of linear search is big O of n, where n is the number of elements in the array. Regarding space complexity, linear search only requires a constant amount of extra space for variables. Regardless of the size of the array, it uses a few variables such as the target value, loop index, and a flag to track whether the value is found or not. As input array size increases, the amount of additional space used by these variables remains constant. Thus, the space complexity of linear search is big O of n, which indicates that it uses constant space and is not dependent on the input size. This makes linear search memory efficient and suitable for situations where memory usage is a concern. Let us discuss some advantages and disadvantages of a linear search. First, advantages. First of all, linear search is a simplicity. Linear search is straightforward to understand and implement, making it a suitable choice for beginners and situations where a quick and simple solution is needed. Next, it is versatility. Linear search can be applied to both sorted and unsorted arrays, allowing it to handle various data arrangements without requiring additional pre-processing. It is easy to debug. Since the algorithm involves a simple iteration through the array, debugging and identifying issues are relatively easy. Next, disadvantages. First, linear search is insufficiency. That linear search time complexity of big O of n makes it insufficient for large arrays, as the search time grows linearly with the size of the input. It slows the advanced algorithms when compared to more optimized search algorithms like binary search or hash tables. Linear search becomes notably slower, especially for larger data sets. It is not suitable for sorted arrays. While it can work on sorted arrays, linear search performance deteriorates when compared to binary search, which has a significantly better time complexity of big O of log n for sorted data. In summary, linear search simplicity and versatility make it useful to certain scenarios, but it becomes impractical for large data sets, where more advanced search algorithms can offer significantly improved performance. Let us get the final conclusion for linear search. Okay. Key points of linear search in C language. Simplicity. Linear search is a basic searching algorithm that sequentially checks each element in an array until the target value is found or the entire array is traversed. Easy of implementation. Implementing linear search in C is straightforward, requiring only a simple loop to iterate through the array and compare elements. Versatility. Linear search can be used on both sorted and unsorted arrays, making it applicable in various scenarios without the need for additional data processing. Its limitations. Inefficiency. Linear search has a time complexity of big O of n, which makes it inefficient for large arrays, as the search time increases linearly with the size of the input. Better alternatives. For improved performance on the large datasets, more advanced search algorithms like binary search, big O of log n for sorted arrays, or hash tables, big O of 1 on average are preferred. And when to use other search algorithms. Sorted arrays. For sorted arrays, binary search provides faster search times compared to linear search, making it a better choice. Larger datasets, as the size of the dataset increases, linear search becomes impractical, and the algorithms with better time complexity should be used to maintain efficiency. I hope this session will help you to understand linear search topic. For the notes, you can go and refer the link which was provided in the description. Thank you for watching.